Hello, 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 hello. Hello, dear students. Am I audible and visible to all of you? Am I audible and visible? Hello, 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 hello. Hello, beta. Hello. Am I audible and visible to all of you? Am I audible and visible? That's great. So I guess we need to start the lecture now, right? Basically, this lecture is last lecture of EMI. From Monday, we will be starting AC. So, as you know that yesterday we were dealing with EMI, we completed emotional EMF, right? So in today's lecture, we will be starting with AC generator. I don't know whether you are talking to your lecture with full concentration or like. But I'm not getting your point now. Good job, sir. How to know whether you are taking a lecture with full concentration? But my concentration is always full, no? Look, how you need to just right. You can just my concentration is always on the top point, right? So I guess now let's start the lecture now. One second. One second, beta. One second. I want how can I check mine? Okay, basically now. Basically, if you want to just check whether you are just serious about the lectures or not, analyze your thinking about the particular topic and analyze your numerical ability. Okay. So just remember that if you are very great with the numerical manipulation, if you know how to manipulate your numericals, or if you know that which formula I need to put for a separate numericals, or how to formulate a numerical, right? How to decode it, or which particular topic I can use to get the answer from that particular numerical, that you're on the good, great track, right? So let's start now the class. One second. I guess my screen is visible to you, no? I hope my screen is. One second, beta. Okay, okay, so my screen is visible to you, right? Wait. One second. Okay, so let's start the last lecture of EMI. So today we will be dealing with the last lecture, right? Last lecture of EMI, that means lecture number 7. So in today's class, we will be discussing about first topic is AC generator. First topic is AC generator. Okay, look now. Suppose we are having two blocks. Suppose we are having two blocks or two magnets. Left side is North Pole, right side is South Pole. Between these two magnets, we are having a loop. We are having a loop in this particular manner. In this manner. Okay. One second. One more second. Okay. Am I audible? Am I audible? Huh? Am I audible? Okay, great now. So we're having two magnets, left side north, south, right side south, and we know that due to these particular magnets, we will be having our magnetic field, which is going from left to right. These lines represents magnetic field. Okay. Now, if we somehow manage to rotate this particular loop, okay, if my loop is in this way, now I am rotating this loop. Okay. So what we conclude from rotating this loop? Look now, this pen represents my magnetic field. It is in this way. This hand represents my loop. You can see here the angle between magnetic field and the area vector is 90 degree. And what is the formula for flux? Is it BA cos phi, cos theta? Yes, sir. Cos 90 is 0, so flux is 0. You can see magnetic field direction is same and constant, uniform. Now I am rotating this loop. If I am rotating this loop, what will happen here? Sir, the magnetic flux. So the magnetic flux which is associated with this particular ring or particular loop, that will change. So we will call is angle of rotation, or we can say the angle is varying. Angle is varying. Angle is varying. So what is phi? Flux. Flux is BA cos theta. Now B constant, A constant, but the theta is changing. If the theta is changing, so we can call the magnetic flux also changes. Magnetic flux also changes. If the flux is changing, yes, beta. Yes. Okay, now if the flux is changing, so look, this BA cos theta is for one loop if we are having n types of loops. So can I write now phi equals to n BA cos theta? Yes, sir. By Faraday's law. Let us put the Faraday's law now. So I guess the Faraday law is E equals to minus d phi by dt. E equals to minus d phi by dt. So E minus d by dt. What is phi? Sir, phi is nba cos theta. Okay, so I can write now minus n constant, b constant, a constant. I need to differentiate the cos theta with respect to time. So we cannot differentiate it. So we know that theta equals to omega times t. Theta is omega times t. So now I can write the equation as minus nba d by dt of cos omega t. So now E came out to be minus nba. What is differentiation of cos omega t? That is minus sin omega t. And differentiation of omega t is only omega. So now which implies that my induced EMF came out to be, it is plus nba omega sin omega t. So you can see now that my induced or my EMF came here. It is a function of sine. That means if you need to make a graph of EMF versus time, it came out to be sinusoidal graph. It is what? Sinusoidal graph. It is what? A sinusoidal graph. So if we now want to calculate Emax, for Emax, look, for Emax, what I can write now, nba constant, omega constant. So my sine omega t needs to be maximum. So at what particular value sine omega t will be maximum? So 90, that means 1. I can write E maximum came out to be, it is nba omega only. So what will be current now? Is it E by R? Yes, sir, I can write. So maximum current, now I can write I max is equals to E max upon R. So E max is equals to nba omega divided by R. These are some relations that you need to remember. Okay, done. But the OneNote, no, the OneNote is it in your syllabus, right? It is an application on which I'm just drawing all these kinds of things. You won't get any numerical from OneNote in your examinations. So don't worry about anything. Done? Now look now. So you will get only now. So this was asked back in your NEET examination. The value of Emax. The value of Emax. So now let us start new topic, that is transformer. That is what? Rahul. Rahul beta, do one thing now. Just message me on Telegram, then I will just show you the procedure or the way how to deal with all the 4 subjects. Okay, how to balance your timings between these subjects. Ping me a message to my Telegram channel. Okay. So now transformer. Let us talk about transformer. What is a transformer? No, transformer is in this EMI, na? Look, so transformer. So when we are just dealing with AC voltage, when we are dealing with AC voltage, AC means that which is changing, polarity changes, right? So when we are dealing with AC voltage, due to our usage, based on usage, if we want to increase voltage, sometimes we need to increase the voltage. sometimes we need to decrease the voltage. Okay. So to increase the voltage, to decrease the voltage, what we need? We need a transformer. To transformer is this requirement is that it increases the voltage or it decreases the voltage. If it increases the voltage, so we can call it as a step up transformer. If it decreases the voltage, it is step down transformer. Step up means if it increases the voltage. Step down means if it decreases the voltage. But I am teaching in this particular chapter, no? Don't worry about sir if it came into your AC or not. Okay. Look now. So now, if the principle of AC is mutual induction. It is what? Mutual induction. Mutual induction. So we are having soft iron core, a laminated core, a frame. Okay. On this frame, we are having my wire winded in this way. Here we are placing a AC source. Here we are having a load resistance. That means the output. If current I is flowing, so it is primary current. Number of turns of primary is NP. Voltage is VP or EP. Here we are having secondary current, secondary coils, secondary voltage, secondary EMF. Done? Yes. Transformer is very important topic. You will find numericals no, in every year. IP means current in the primary coil. NP means number of turns in the primary coil. Okay. VP means primary voltage or EP is same as the VP. IS means secondary current. NS means secondary coil turns. VS means secondary voltage or ES means the same. First thing that we need to understand that we are assuming assumption is 100% flux linkage. 100% flux linkage. That means if current is flowing through this, so we are having flux, and flux is entering this loop 100%. 100%. Flux is entering this loop 100%. So we call it as a no loss. So I can write here no flux loss. No flux loss or 100% of flux linkage. It is an ideal condition, but still we are just taking this as an assumption. Done? Now look, according to the Faraday's law, E equals to minus d phi by dt. I can write here total. Done? Clear now? Phi total means number of times of flux. So I can write it as a minus n d phi by dt. D phi by dt. One second, beta ji. One second. Okay. Look now. So I can take n, this is d phi by dt now. So we are having two parameters. One parameter is, I can write here E primary equals to minus n primary d phi by dt. First equation. Second, E secondary equals to minus n secondary d phi by dt. Change in flux is same no? In both of them. I will just divide the both. minus minus cancel out, this flux cancel out, so I can write E primary divided by E secondary came out to be N primary divided by N secondary. Done. And one more thing, we are having 100% efficiency. 100% flux linkage means 100% efficiency. That means power primary input power equals to output power. Power is V into I or E primary. So E primary I primary equals to E secondary I secondary. I can write E primary divided by E secondary came out to be I secondary divided by I primary. Done. So therefore, yes, secondary is output. Secondary is output. So we are having, look, just take this one and take this one. So now the important thing from this particular topic is E primary divided by E secondary minus V primary divided by V secondary equals to N primary divided by N secondary minus I secondary divided by I primary. So you need to remember this particular formula only from this particular things. If let us suppose, if not 100% efficient, if not 100% efficient, so we are having formula for efficiency now, that is output power divided by input power multiplied by 100%. So this formula you need to remember to get my what? To get my efficiency of my transformer. But no worries, no? No worries. If I'm not getting a response from any student, no, there is no issue, right? I am teaching here, no. If you want get to something, no, you can be in the class. No issue, no. I'm not forcing you to be in the class. If they are just getting any interesting thing in this class, so they will be in the class, no. If let's suppose my class is boring and they're not getting their great content from it, there is no issue, no. Nothing like that. Okay, look now. So we are dealing with transformer. So we are having two types of transformers. One is step up, one is step down. Step up and step down. In step up transformer, if voltage in secondary is more than voltage in primary, step down means voltage in secondary is less than voltage in primary. We know one thing now, Vs divided by Vp equals to Ns divided by Np. So therefore I can write Ns is more than Np. In step up transformer, the number of windings in the secondary part is more than that of the primary part. I don't know, beta. In secondly you can write that number of secondary parts is less than number of primary. How, sir? Look, if I am making a diagram of it, no, look, you can see here number of primary and number of secondary, and number of primary is less than number of secondary. Clear? It is obvious, no? You will see now number of primary less than number of secondary. So you can see here number of secondary more, so it is step up transformer. Step up. One more example. Look. See here, number of primary more than number of secondary. So I guess this one is step down transformer. This one is step down transformer. Beta, don't worry, na. Be in the class, just get these things at the end. I guess you are in my Telegram group now. You will get the notes of it. Don't worry about anything. Don't worry about anything, right? Okay. Look now. So you will get some numericals based on the transformer. Those numericals are very easy, very easy, right? So in the next chapter, I will be showing you the great numericals from this part. But now I want to just complete the syllabus as of now. Then we can just conclude the whole things, right? Next part is induced. Next part is induced electric field. Induced electric field. Okay. We know from the electrostatic what is it electric field now. But here what we are having induced electric field. Look, there electric field line is never form closed loops. But here induced electric field is always in closed loops. Okay. Electric field conservative. Here induced, it is not conservative. Sir, what is the main reason behind what is induced electric field? Let us take an example of it. So if this is a loop, inside the loop we are having a magnetic field in this particular manner, and this magnetic field is increasing. As per Lenz's law, there will be a current which will flow in this manner, which will flow in anti-clockwise manner, Okay. Look, we are having here magnetic field, right? We are here having magnetic field. So initially my B is present and magnetic field is not exerting. It is not exerting any force. On stationary particle. Initially, when we are having this loop, initially electrons are stationary, right? But when we are having magnetic field here, these particular charged particles start to move. But you can see, initially these particles were at rest. If they were at rest, no magnetic field being applied on it. So we concluded that no, we don't have here a magnetic field, we are having a different field. That different field is known as induced electric field. And this induced electric field is a vector quantity, and its direction is same as that of the induced current. These are some points. Why, beta? Why means? What is the meaning of why? What is the meaning of why? Huh? What is the meaning of why? Look, these are some little topics, no? These are not that much important, no? You need some information about why there is an induced electric field. So initially, if my loop is present in the electric field, we know that initially every particle is at rest. If every particle is at rest, but still the particle is facing some forces, why it is getting a force? There shouldn't be any magnetic force. Why? Because the particle is at rest. As the magnetic field, no stationary particle get any kind of forces. So we conclude that no, there is another kind of forces or another kind of field, that is the induced electric field, which is being exerted on the charged particle and they start to move. But I can see now in this class, look here now. So here the property of induced electric field is same as that of the magnetic field. So magnetic field is the closed loop. Here as well, the induced electric field is the closed loops. Like why? Because look, you can see this electron is revolving around the loop continuously. So there should be a field which is just pushing it in a complete manner. So we are having and what? Induced electric field. Induced electric. Done now. Last topic. Look, this is induced electric field is a very simple topic, a short topic. You don't need to do a PhD on it now. The quantity that I am giving you, it is very sufficient for your examinations. Don't be so sad now. Why I started teaching only this kind of material, right? Because you will get the numerical from these things only, right? Don't worry about anything. Simple thing is you will get numerical from these parts only. Look now. Last part is eddy currents. Last part is eddy currents. What is eddy current? Here, if we are having North Pole, South Pole, let us suppose we are having a loop. We are having a loop, and loop is just swinging. It is swinging across it. No? It is doing like this, no oscillation like this. So we observe that speed gets reduced. Speed gets reduced, right? So we conclude that whenever we are having a closed loops, a plate, it's a plate, no? Whenever we are having, why is clear? Why is clear means? So we are having some sort of plate in which my flux is getting changed. Okay, so we conclude that yes, there is a speed reduction due to of the current production inside the plate, and those currents are, they don't have any specific direction. Why? Because it is not a rod, it's a plate. So we assume that these are in the form of circular things. So these circular things are known as what? Eddy currents. Okay, so to minimize the eddy current, we need to minimize the area. If area minimize, current will minimize. How, sir? Look, we know R equals to rho L by A. If we decrease the area, R will increase. If R increases, I decreases. Then, so in today's class, look, we are having this much of quantity in your examination, right? We don't have any different things from this. Okay, so you will get numerical from these parts only. Okay, so what you need to remember from today's class, that is this part. Look, so you need to remember this equation, this one. Then you need to just think about where you need to do step up, where step down. 2 points from this particular class, then this part and this part. Okay, and how to do like this one now. Okay, so these two things. So only these things you need to remember from today's class. So I hope that you are getting my point now. So from Monday I will be very good to start the AC chapter. Today I'm not very great now. My health condition is not just allowing me to just be right. Okay, you can see my face now, it is all dull, right? But I know I'm having a lot of commitments with you now. That's why I'm not changing anything. Okay, but still you can see my face now, it is dull, right? I don't have any kind of energy now. Okay, beta. Thank you, beta. Thank you. Bye. Good night. Thank you. Bye. Good night. Good night. Thank you. Bye.